Okay, Wildcats. Today we're looking at Tuesday, March 26th, exponential function transformations on page 63. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at exponential function transformations on page 63. F of x equals negative a times b to the negative x minus h plus k, where b is the base of the exponential function. When the negative in front of the a reflects over the x-axis, when a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the x inside the parentheses, it reflects over the y-axis. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. Would update your notes. Now your notes updated, let's take a look at our examples. All right, exponent transformations. When y equals a times b to the x, tell whether the function shows growth or decay, state the y-intercept, state the domain and range. Okay, so the b value is what's in the parentheses, so that's 0.01. The a value is the number in front of the b, so it's -2. Okay, since it's negative, it's decay. And the a value is your y-intercept, so the y-intercept is 0, -2. The domain for exponential is always negative infinity to positive infinity. The range, since it's negative, it reflected, so it's coming from negative infinity to 0. All right, example number 2. The b value is within the parentheses, so 1.2. The a is in front of the parentheses, so 5. It's positive. The a value is positive, so it's growth. The a value is the y-intercept. So the y-intercept is 0, 5. Domain is negative infinity to positive infinity. Range would be from 0 to infinity. Okay. Example 3. So the b value is in the parentheses, so 0.98. Now, since the b value is less than 1, it's decay. Okay, the a value is 2.5, which is the y-intercept. Okay, the domain is negative infinity to positive infinity. And the range is 0 to infinity. Now, I think I misspoke in example 1. It's because the b value in here is less than 1 is the reason why it's decay, not because it's negative. I apologize for that mistake. All right, let's look at use the graph of f of x equals 2 to the x power. Graph the exponent function using transformation. State the asymptote, domain, and range. Okay, so here, let's look at the transformation first. It's up 5 units. And actually, let me take a step back. Let's graph the parent function in orange. Now you'll notice the parent function has an asymptote at y equals 0. Okay. Now, if the transformation goes up 5 units, the asymptote goes up 5 units. So 1, 2, 3, 4, 5. Okay, so the asymptote is at y equals 5. Oh, actually, I'm sorry. Yep. Okay, so this is y equals 5. The y-intercept would be when x is 0. So you have f of 0 equals 2 to the 0 plus 5. Well, any number raised to 0 power is 1, so 1 plus 5 is 6. So your y-intercept is 0, 6. Now, once you understand where the y-intercept is, the curve is identical, just moved up 5. So your curve is here. Okay, domain is from negative infinity to positive infinity, and range would be, it was from 0 to infinity, but it moved up to 5, so it's from 5 to infinity. All right, go ahead and finish up example 4. All right, let's take a look at example 5. Okay, now, again, I've graphed the parent function exponential here, so let's do that in orange. Remember, the parent function has an asymptote at y equals 0. Okay, the transformation here, the minus 3 tells us that we go right 3 units. That means the asymptote stays the same because it didn't go up or down, so the asymptote's at y equals 0. Okay, now to find the y-intercept, you plug x equals 0, so you have f of 0 equals 2 to the 0 minus 3, which equals 1 divided by 8, which is 0.125. So your y-intercept, we can round to 2 decimal places to be 0.13. So your y-intercept is about right there. Now, that point really doesn't help you graphing. So what I would use is, I would use this point right here, 0, 1, and let's go to the right through with that. So 1, 2, 3. So we have our function there. Now, domain is still negative infinity to positive infinity, and range would be from 0 to infinity. All right, so go ahead and finish up example 4 and 5. All right, let's take a look at example 6. All right, state the transformation. Okay, so let's do that. Okay, so we have several in this one. The negative reflects the x-axis. Okay, we have a vertical compression of 1/2. And then we have down 2 units. Now, the asymptote is at this number, so y equals -2. Now, the y-intercept is why I left all the space for this work. To find the y-intercept, it's when x equals 0. So you have f of 0 equals negative 1/2 times 2 to the 0 minus 2. Well, that equals negative 1/2 minus 2, which equals negative 2.5. So your y-intercept is 0, negative 2.5. Okay, domain is negative infinity to positive infinity. And range would be, because it reflected, it's coming from the negative infinity to negative 2. So go ahead and finish up example 6. All right, now let's look at example 7. Okay, now I've used e because e and the power of 2 are pretty much in the same exponential family. Okay, so transformation, we have a vertical stretch of 4, and then it looks like we go left 3 units. Okay, the asymptote is, assume that that's plus 0, so our asymptote is y equals 0. Now, for the y-intercept, it's when x equals 0. So y equals 4 times e to the 0 plus 3, which equals 80.34. So your y-intercept is 0, 80 point. And really, I like to be consistent. And since I'm rounding one decimal place here, let's round one decimal place here. So let's just 80.3. Okay. The domain is negative infinity to positive infinity. And the range is 0 to infinity. All right, example 8. Transformation. Looks like we have a vertical stretch of 3, left 2 units, and down 1 unit. Okay, the asymptote, that's this number right here, so y equals negative 1. The y-intercept is when x is 0, so f of 0 equals 3 times 10 to the 0 plus 2 minus 1. So f of 0 equals 299. So your y-intercept is 0, 299. Domain, negative infinity to positive infinity. And range, it's always starting this number if you notice from each of the examples. So it'd be from negative infinity, or negative 1 to infinity. All right, go ahead and finish up your examples and then start working on your assignment. And have a wonderful Wildcat day.